Here we are at part 2. What we're going to look at is a new kind of function where we're going to take something familiar like y equals x, and you'll recall y equals x is a graph that cuts exactly through the first and the third quadrants. There's the line y equals x. It goes forever and ever and a day. So we have y equals x. And it's also going to involve y equals negative x. So let me remind you what that looks like. And it goes forever in 2 days. Y equals minus x. All right, and we're going to combine that with an old dear friend, y equals sine x. So that goes up to 1, down to 1, like that in 2 pi radians. And this was pi over 2 where it peaks, and 3 pi over 2 where it bottoms out. So, all right, that's just a review of those functions. And now, I'm wondering, and I'm sure you are as well, what happens when I put them together? Y equals x sine of x. What would that look like? Well, that will be a very interesting function. And I will explain it as best I can and see what you think of it. Y equals sine of x. Let's recall that the value of sine of x, just that alone, just zero in on that, it goes up to 1 and down to minus 1 and has values in between, but never greater than 1 or less than minus 1. So what happens, suppose we have pi over 2, pi, 3 pi over 2, and 2 pi. And we might even go a little further than that. Let's see what happens. What happens if I put in the value pi over 2 into this function? Well, that function that's right here at pi over 2, look what it does. It peaks at the value of 1. So if this becomes a 1, and the value that we are evaluating is pi over 2, this whole expression is going to become pi over 2 times sine of pi over 2, which is a 1, so we get pi over 2. So we're going to get pi over 2 over and pi over 2 up. And that line y equals x will go right through that point. So let's keep that line there for reference. And that is going to happen again. When's that going to happen again? Well, we have a cyclical graph here. So at pi over 2, this is going to peak. And then since the period is 2 pi, if we go over 2 pi radians from pi over 2, it's going to happen again, which is going to be, if this is 4 pi over 2, this would be 5 pi over 2. So let's go out one more, and I'll extend through the roof here. Wait a minute, I gotta make a hole in the roof so we can go that far. So that's going to happen again when sine is 5 pi over 2, because the value is 1, and this will be 5 pi over 2, which is now going to be up to here. Alright, so we've got 2 points on this glorious graph. Let's talk about what happens at pi, where sine equals 0. What's going to happen to this function at pi, the value of pi? We'll have pi times sine of pi, which is pi times 0, which will be 0. So, and that's going to happen again every 2 pi radians. So it's going to happen out here. All right, so we got a couple pieces of the puzzle, but not enough to draw it in all its glory. So let us evaluate what happens here at 3 pi over 2. we put a 3 pi over 2 in this function, this becomes negative 1. And we have negative 1 times 3 pi over 2, which is negative 3 pi over 2. So I'm going to put in that other graph because right there it's going to match but be negative. And that's going to happen again, 1, 2, 3 in 2 pi radians. So going out of the screen here, it's going to be on this line, but it's on the negative side here, the negative y equals negative x. All right. Maybe you can see what's going to happen now. And here it's going to be 0 because sine function is 0. So I think you can see it's going to go up like this, 0 like this, then down like this. And at 2 pi, you can get a 0 there. And this looks wrong. This will be another. This is, it's going to be not 4 pi. If that happens it's going to zero out that happens every pi radian. So it's going to happen again right here. All right, so that one was off a little. Up and down. And now you can kind of see what's happening. If you evaluate the function on this side in a similar way, looking at where it peaks and valleys and where it crosses 0 and putting it in here, you'll see a similar thing happens. First of all, it's going to go up, then it's going to 0 out, then it's going to go down, 0 up, out, and then it's going to go up, and so forth. So let's see what it looks like on the calculator. All right, y equals, let us go, I had that plugged in here, and I'm going to turn that function on by hitting enter. Just a second. Enter, enter. You can turn functions on and off by hitting the equal sign and hitting enter. So I had some other stuff in there. So, all right, I think that'll graph it now. So let's see what we got. How cool is that? Now we're going to put in the lines y equals x and y equals negative x. Now for the revelation of the name of this. This is called a damped function. Damped function. And you can see it's dampened as we go in. And an example of that, like if you had a spring and you had a mass hanging from the spring and you pull it down and release it, it's going to go up and down, but not quite as far, and then not quite as high, and each one will become less and less until it's back where it started. And that is very much like we are observing in this function, the damped function. Let's look at one more. I'll kind of just have you put it in the calculator and see if it'll match. So put this one in the calculator. Y equals e to the minus x. Y equals e to the minus x sine x. So this damped function is going to be fenced in by this function. And you have seen that function in Algebra 2. It looks like this. It's an exponential function, and the negative sign causes it to get lower very quickly. And if we look at its negative partner, that will form the other fence. So this is y equals e to the minus x. This is y equals negative e to the minus x. So this negative sign just flips that across the x-axis, and the sine curve should be fluctuating in between, something like that. So let's see if you can get that on your calculator. Make sure you're in radians and plug in this function and try different windows. Like if you go to the zoom menu, there's the Z standard. I don't think you'll see very much of it there. maybe Z trig. There's under the zoom menu. Also, you could zoom out. Just get a bigger picture. If you hit the zoom out function, you have to hit enter to get that to do that. All right, that's it for damped functions, and I would like to see that on your calculator. So if you can get a good picture of it, leave it on your calculator so you can show me in the morning. All right, that's it for tonight. Over and out.